This is emergency for the first time in America.
This is Jim, and
Receiving this message. We are Ken Jennings and John Roderick. We speak to you from our present, which we can only assume is your distant past, the turbulent time that was the early 21st century.
Fearing the great cataclysm that will surely befall our civilization, we began this monumental reference of strange and obscure human knowledge. These recordings represent our attempt to compile and preserve wonders and esoterica that would otherwise be lost.
So whether you're listening from an advanced civilization or have just reinvented the technology to decrypt our transmissions, this is our legacy to you.
This is our time capsule. This is the Omnibus. You have accessed entry 524.JB3709, certificate number 41220, Geomagnetic Reversal.
Now, in your go bag, for when the earthquake hits or the oceans freeze with Ice 9 or whatever.
I have it right here.
What's the thing called? The carry?
Everyday carry.
Everyday carry, right.
Or a bug out bag or a, small bag.
Do you carry a compass
Yes.
every day?
Yes.
Not the one in your cell phone?
No.
Because I don't think I own a compass of either kind. I can't draw circles,
Right.
and I can't find Canada.
I have both kind right here.
Do you have a combination? What a great item that would be, right? A little sharper image, compass.
But I have an old drafting set somewhere here within easy arm's reach. But I love an analog compass.
Yeah, I feel like I should own one. I remember distinctly getting my first compass when I was, 5 or 6 years old. I got some kind of Fisher-Price outdoors kit, my first nature or something.
Times have really changed, haven't they?
Can you imagine giving a kid a little orange plastic compass and being like, here you go. Here's a book about bird songs.
It was probably a great compass.
I think it had a little canteen. I'm trying to remember what else it had. A plastic canteen. Now I really want to look this up.
But you were a scout.
Yeah, but I was an indoor scout.
But I
Right. I only wanted like the graphic design merit badge or whatever.
Right. The macrame plant holder.
Yeah, I was
merit
mostly there
badge.
for the lanyards.
Yeah.
Oh, I found it. Utility hiking belt. Yeah, this is all coming back to me. So it's got this green and orange kind of Batman utility belt, but the things you hang on it are kind of a yellow canteen and a rubber holder. There's a blue spyglass, that famous thing that we all take hiking.
Excellent, yes.
A plastic pirate's spyglass.
I'm so embarrassed to say that I have one in my, not a play one, but like a real one.
I guess binoculars were beyond the budget for whoever was putting this together, Mr. Fisher or Mr. Price.
I've never understood why there are a lot of binoculars in the world, why there aren't more monoculars, spyglasses.
For people with eye patches?
Well, that, but also it's so dramatic to like pull it out and like open it up and peer through it. It's
John, what kind of bird is that? And then you have two options, and only one of them has a whoosh.
Yeah.
I think this one had like a 1.2 times magnification or something.
Yeah.
Kids could not be trusted with actual spyglass.
So
you put it up and everything would look exactly the same, but you'd be like, ooh, the circle is smaller.
Someone got me a novelty cane not very long ago that if you unscrewed the head of the cane, inside there was a telescope.
Wait, a telescope?
Yeah, that pulled up and rotated out and then would.
Oh, it's standing like a surveyor's thing?
Yeah.
You're not sticking the whole cane up and out of your eye.
No, the telescope came out of the cane and then rotated. But it was this incredibly elaborate.
Where did H.G. Wells come to your birthday party?
Exactly. It's such a steampunky thing. It was such a construction, right? It had all these parts, all this brass. It was hinges and the cane itself was collapsible. But when it came to the telescope, it was garbage. it was just glass. Or it had a magnification of 1.2.
Was it a plastic blue Fisher-Price one from 1983?
No, it was like a solid brass thing that had been made in Pakistan. But somehow in all of this, like putting a couple of halfway decent glass lenses or even plastic lenses in it, but lenses rather than just clear glass. And so as soon as I realized that it didn't function, it became an insult to me, right? I didn't want it in my house. This doesn't work. This isn't anything.
This is not the kind of affectation I want to be seen with.
I would absolutely rock this affectation if it did something.
If the optics were better. I distinctly remember the little orange compass that came with this Fisher-Price set, and it wasn't very good. But I remember briefly being confused that this was not your brass hinged construction. There was no mechanics here.
Right.
Magically, there was a little piece of metal that would always point the same way, and I did not buy it.
Right. Oh, you didn't?
Well, I bought the item.
I see what you're saying. No, you probably didn't buy the item either.
It was a Christmas present. I had no money. But
you thought there was a trick? You didn't believe that this was natural?
To this day, it doesn't seem super plausible.
Mm-hmm.
Like if you were playing a video game and there was a very thin piece of metal in the game that would always point to a fixed point in the game, you would think, this is a contrivance. This is to make the game work. It just doesn't seem very likely that our planet is built in such a way that a thin piece of the right metal will always point the same direction. But it does. It's a crazy thing about being on Earth, but not Venus and Mars.
You
compass is worker.
You and Shaggy 2 Dope share a confusion about this.
Who?
This is
this your new girlfriend?
No, my girlfriend isn't named Shaggy 2 Dope. No, that is one of the two lead singers of the band Insane Clown Posse.
Oh, from Insane Clown Posse.
Yeah.
Wait, they do a song about how compasses are fake?
They have a song in which they're describing all the like amazing miracles of the world. Like it was kind of meant to be like a spiritual tune, like maybe a song where they were venturing outside of the smaller world to make a metaphysical tune.
We're going to be a slightly saner Clown Posse today. We're going to slow things down.
But one of the lines in the song, in order to communicate like how majestic creation is, I'm pretty sure it's Shaggy 2 Dope, says, "Magnets, how do they work?" Or I think that's something like that.
Around it's all astounding. Water, fire, air, and dirt. Magnets, how do they work? And I don't want to talk to a scientist.
Expressed some incredulity about like magnetism.
And he's going to blow the lid off this thing.
And he was roundly mocked by all the people that are just looking for a reason to hate Insane Clown Posse.
Can you imagine going to an Insane Clown Posse show and you're a huge fan, of course?
Right.
I don't know what you would call such a person.
Right.
But let's just...
you would call them a juggalo.
Right. There is a word for someone who's an insane fan of Insane Clown Posse. So you're with your Juggle Bros, and then Insane Clown Posse says the sentence you don't ever want to hear in life, which is, "We're going to play some of the new stuff." And then it's a song about magnets.
I think that that juggalos typically, I'm afraid that we're going to have to talk about the juggalos here on
I can't believe we haven't done a juggle show.
It's on a juggalo juggle show.
That's right.
It's on my list of shows to do, but their fans tend to be very supportive of their new material. Of all of the ways in which you look at the juggalos and think like you've got their number, do
they surprise you?
They consistently defy any attempt to be like, "Oh, those guys are just like this." Turns out they never are. Turns out they are always not what you think.
Juggalos are large. They contain multitudes. I guess.
That's right.
But moving from the moral compass of the juggalo to the physical compass of our world, it's been a real boon to navigation that the Earth has a magnetic field and a magnetic pole. Although, of course, that when compasses point north, they are not pointing to the North Pole.
They are pointing
upon which the Earth rotates on its axis.
Infuriatingly, they are pointing to the magnetic pole,
which is tantalizingly close, currently about 300 miles away.
Oh, that's so infuriating.
When you were in Alaska, like, are you close enough that makes a difference?
Yeah,
it's not pointing north; it's pointing north-ish.
Yeah, there's enough variation that it's noticeable as you head further north. up there, but
Yeah, like if you're trying to find the North Pole, like because you're an explorer with a dog team, don't use a compass.
but most of the time, exactly, you'll find the magnetic North Pole, and this is true of the South Pole too.
They're both moving. Did you know this?
Yes.
The geographic one, you would think wouldn't move. You'd think the Earth would just turn on a fixed axis, but it does not. That axis does wobble as the Earth's mass shifts, like the balance of it.
So every time we run really fast across the room, we have made an imperceptible change.
Every time you decide, this IKEA futon actually needs to go on that side of the room,
Right.
it slightly moves the Earth's
The Earth goes
magnetic.
wugga, 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 wugga.
Yeah, it makes that noise too. And everybody's like, oh, John moved the futon. Today, I mean, most of these events would happen on a bigger scale today. So I imagine the Earth's geographic pole is moving faster today than it did 100 years ago. Because, if ice sheets melt, for example,
Right.
that moves a lot of mass of water to a point or a latitude where it didn't used to be. And actually, mostly the effect has nothing to do with ice. It's actually where, this is a good one for the futurelings to think back. It's because we're depleting aquifers so fast.
Can that really have a greater impact than glaciers?
It does. Parts of the Earth that used to be nice and heavy and full and pregnant with water are now getting dry and desiccated to ready the Mad Max hellscape that is to come.
Oh, wow.
And all that water is spread out somewhere else, further from the center of the Earth and probably at a different latitude. So
That's going to really affect at some point plate tectonics, right? I mean, the plates which were already the lighter ones, the ones that had floated to the top,
or they wouldn't be
the
here.
continental ones, right?
They're the frosted flakes floating on the milk of the crust.
They're now lighter and lighter and can only be, one assumes, they're going to start being more mobile.
They're just going to be whizzing around.
Is this some crazy conspiracy theory that I'm stumbling into, or
Plate tectonics is speeding up.
are
I think
geologists thinking about this?
I think it's just a conspiracy of atlas publishers.
Yeah.
You're going to have to buy an atlas much more often.
Ugh, I'm spending so much on atlases now.
Borneo is so much closer to Malaysia. I got to go back to the bookstore, I guess.
But the geographic pole does not have any influence on the magnetic pole.
You think it's a coincidence, John?
Are they
on this vast planet that they're just 300 miles away?
Well, how are they related? How does the one relate to the
It's
other?
an interesting question. Why does the Earth's magnetic field tend to align north to south instead of west to east, for example? And I think it does have to do with rotation. Now, we're getting into a lot of supposition here.
Okay.
Because we, at our current era, futurelings, our science is still beginning to model why the Earth has a magnetic field and how it does what it does. But it has to do with convection of liquid rock in the molten, core of the Earth, the outer core of the Earth. There's liquid rock moving around, and a lot of it is iron, which is a ferromagnetic mineral. In most substances that are just sitting around here, the atoms all have electrons whirling around them, and each of those electrons has a different spin up and down. But typically those electrons are paired. So every time you've got an electron spinning up, you've got another one spinning down, and there's no weird ill effects. But there are certain kinds of substances that are ferromagnetic. That means they have a lot of unpaired electrons. They've got enough electrons lining up with a certain spin that the whole thing produces a magnetic field, the same way that if you ran current through an electromagnet, it would produce a magnetic field.
Are there elements that have more magnetism than iron? What is the most magnetic of all of the elements?
Well, iron is not the only ferromagnetic element, even though it's the one that gave ferromagnetism its name.
Right.
Nickel, which is the other component of the core, and cobalt are also ferromagnetic metals. There are a couple more that are not, that lose their magnetic field at a low enough temperature that we don't care. Like gadolinium, for example, is ferromagnetic, but only until 66 degrees Fahrenheit.
Oh, and then
On a nice balmy day, the magnet just turns off. So if you're going for a walk with your gadolinium compass, as long as it's a brisk morning, you'll do fine, but you got to get home before noon. Same with dysprosium. It has a magnetic field until negative 300 degrees Fahrenheit or negative 185.15 Celsius, futurelings.
so I imagine there's a lot of nickel in the core. Is there a lot of cobalt?
There's some cobalt. The interesting thing is there are alloys of these things that are more magnetic than either. There's an iron cobalt alloy that's more magnetic than either. And I think more recently there's some kind of iron and nitrogen compound, which is now the most magnetic material on Earth. So maybe perhaps in order to refute Insane Clown Posse, scientists are trying to come up with more and more powerfully magnetic substances.
Do you have magnets?
Like on me right now?
Well, in
like,
general.
Do you see this bracelet? This is for my arthritis.
That's a copper pyramid. What are you trying to pull? No, but I mean, do you have magnets as a part of your collection of things?
My life?
Yeah.
We currently have a fridge that is not magnetic.
Yeah, my problem.
Don't you? These new stainless steel fridges are not magnetic.
I almost sold my house back to the people. When I got here, the first thing I did was put a magnet on the refrigerator and watched it slide to the floor, and I was like,
no, I cannot live here.
So awful.
You just need to put a powerful electromagnetic in the fridge.
Why is stainless
or foods with a lot of iron?
Why is stainless steel not magnetic, Ken?
Too much nickel.
What?
Nickel is apparently less.
But nickel is magnetic.
But not enough. You've seen the thing where the magnets kind of stick but don't, right? Nickel's less magnetic than iron. We actually put a magnetic chalkboard in our kitchen just so we could have a place for magnetism.
Yeah.
Because on Passover, if Magneto comes over,
sure,
he is Jewish.
I know.
You want him to feel...
It's part of his origin story.
It's part of his slightly tasteless concentration camp origin story.
I'm not new.
You want him to feel at home. You want to have a little magnetic alcove in your house. Do you have... I would venture a guess that you have cool, old-timey, horseshoe-shaped magnets with peeling red paint. Do you have a box of those somewhere?
I have a lot of magnets.
Are you Wile E. Coyote? Are you going to make me eat ball bearings?
They're all part of my scheme to get that rascally roadrunner.
Got to put the ball bearings in the birdseed.
For whatever reason, whenever I go to some science place, which is not infrequent, I get magnets.
No, and is a science place in this story, is it like the CERN laboratory in Switzerland?
Yeah,
or is it like
right.
the gift shop at a children's museum?
Both things. But I was at Los Alamos one time, and
seems like that's the story right there. Way to bury the lead. So I'd snuck into Los Alamos,
and there was a box of like surplus magnets, like little ones that looked like they'd been part of some kind of core sample.
They weren't refrigerator magnets. What if they had like Snoopy and Woodstock, and you were like, "Can I take these?"
They're super powerful. These things. They're small. They're like a roll of Rolos. They're like
I've seen those.
Yeah, and they're like gnarly.
They're some kind of super magnetic as you can get alloy.
They're super magnets. How do they work?
Super magnets. How do they super work?
So I have some of those, and I've always been fascinated by magnets like any kid. And I don't have a use for them. It's not like I'm trying to mess with Magneto or something.
The ones that are strong enough will actually go through skin, so you can put one on each side of your earlobe, or take a little pinch of arm fat and magnet that up. It's a cheap temporary body mod.
These are strong enough that they will do that and kind of hurt.
That's what you want.
They kind of hurt you. They're so strong.
That's how you feel like you're really part of the body mod community. If the magnets you put on the inside of your cheek are actually kind of hurting, and you're wishing you hadn't done that.
If you aren't hurting yourself, you're not part of the body mod community.
When it comes to meat, quality makes a huge difference in texture and taste. And even though it might be better for you and the environment, a lot of the higher quality meat you find at the grocery store is just too expensive for most people's budget. Thankfully, there's ButcherBox. ButcherBox believes everyone deserves access to high-quality, humanely sourced meat at an affordable price. That's why each month, ButcherBox ships a curated selection of the finest cuts right to your home. Choose from 100% grass-fed and finished beef, free-range organic chicken, heritage pork, wild-caught Alaskan salmon, and sugar and nitrate-free bacon. No antibiotics, no added hormones, just meat the way meat should be. And right now, you can get 2 pounds of ground beef and 2 packs of bacon absolutely free, plus $20 off your first box when you visit butcherbox.com/iHeart or use the promo code iHeart at checkout. That's butcherbox.com/iHeart or use the promo code iHeart at checkout.
You mentioned plate tectonics, and that actually has a bearing on the study of geomagnetic reversals. So I guess to conclude my point. The Earth does have a complicated convection of magnetic stuff going on. And as these ferromagnetic materials with their unpaired electrons swirl around under our feet, they cause a magnetic field to surround the planet. And because they are moving as a result or in synchrony in some kind with the rotation of the Earth, that field aligns north-south. But here's the thing. What if it didn't? We all know, of course, that compasses point north. But what this entry presupposes is, what if they didn't? What if they pointed south instead? Because that has been known to happen.
Well, so I've always wondered if the polarity of the world just flips.
Boing.
And now north is south and south is north.
We call that geomagnetic reversal. I don't know if we said that yet.
Good.
Helpful.
I stumbled into it.
They actually have a word for it.
If that happens,
kind of like when I discovered the word juggalo accidentally.
Does it do anything? What changes besides everybody's compass flips around?
Well, South Dakota is now on top of North Dakota.
No.
You got to rename a bunch of states.
I already have one of those maps with Australia on the top.
You're ready to go.
I am.
I'm just going to have to turn mine upside down and learn to read the Roman alphabet upside down, which I think I can give me 20 minutes. I'll be good. We don't actually know what happens, but we know it has happened. And this is a fairly recent discovery. It was not until the 1920s that a Japanese geophysicist named Motonari Matuyama, in collecting samples of basalt, the volcanic rock, was surprised to find that some of them did not have the polarity he was expecting. Now, these rocks that have hematite and magnetite and all these other magnetic minerals in them, they're crystalline. They have a crystalline structure. And when you have these little tiny bits of magnetic mineral, the crystals align with those. So by, actually inspecting the magnetic qualities, so the rock, the whole basalt forms according to the magnetic field that was there when it cooled.
Right.
It's like a fingerprint that stays. So by examining these rocks, the crystalline structure of these rocks, and using a magnetometer to look at their magnetic field, you can actually tell what were the magnetic conditions under which this basalt was created. And it was known that some basalt seemed to have a south-facing polarity instead of the north one we would expect, which puzzled people. But Matuyama was the first to find that they seemed to come in chronological tiers. Like a certain time period would produce a bunch of north-facing basalt, and then a different time period would produce south-facing basalt. And he had a theory that there must have been chronological periods, which we now have a name for. We call them crons, in which super lazy name.
But was somebody working at Marvel at the time? What do we call this? Crons.
If these be crons. And a cron is a period where the Earth's magnetic field was pointing to a different place. And yes, if there's times when it's north pointing and times when it's south pointing, there must have been a terrifying flip. And what is that even like?
I don't understand when I hear stories like this. He picked up the rock. He took it to the lab. He put it in the magnetometer.
Yeah, the magnetometer.
But when he picked up the rock, he didn't put a chalk mark on it, noting its orientation where it lay.
It's not.
So he's looking at it under the...
The Earth's magnetic field does not turn the rock like a compass needle on the ground, John.
Well, I know, but when you're looking at a rock just sitting, out of context, and you look at its crystalline structure, how can you tell that it's out of alignment with the place that it was sitting? How would you have the relative...
Oh, I think he's looking at different levels. You know how... So this is a time when there was no radiometric dating of rocks, which is weird. We hadn't yet figured out that, because of nuclear decay, you could look at a rock and see how much of this isotope of carbon it has in proportion to that isotope of carbon, and therefore it's such and such years old. So what he's probably doing is placing rocks in different strata, the same as the Victorian geologists would have done, and said, here you can see a different kind of sediment, this must have been underwater, etc. So he's kind of dating things informally that way. And between those two layers, there's a difference in the polarity of the Earth.
I see.
And he thinks there's a pattern here. Interestingly, this discovery came before we even knew about plate tectonics. And the two are related.
Wow.
People have known for centuries that it looks like Africa and South America
fit together.
Should be, they're like friends who are like, you two really need to be... You can just tell that you two should be together.
Uh-huh.
And this had been observed for a long time, but nobody understood what mechanism possibly could have yanked Africa and South America apart and created the Atlantic Ocean. And it wasn't until the 1950s when U.S. geophysicists started using magnetometers and Matuyama's theory that the Earth's pole had flipped several times to study the magnetic field at different portions on the seafloor, that they found, indeed, not only were there different north-south polarities, but they went in stripes. The bottom of the Atlantic Ocean is marmorated.
Really?
Yeah, and what that means is that new seafloor is being created at the point in the middle of the Mid-Atlantic Ocean where Africa and South America are moving apart. And so you can see stripes where new magma came out and cooled and formed new seafloor during a North Pole period. And then abruptly, there's a South Pole period. Then there's another North Pole, then a South. And you can tell by the width of the stripes either how fast the seafloor is forming or how long that particular cron was.
Sure, because the seafloor is forming on a time scale similar to that in which the polarity is flipping.
Yeah, so we can use that to estimate, and now that we have radiometric dating of these rocks, we can estimate much more closely what these periods are like. And it appears to be an average of a few 100,000 years.
Huh, that short.
But there's a lot of variance. There are supercrons, for example, that last like 50 million years, like from the whole end of the Carboniferous well into the Permian period, 50 million years of no magnetic field switches. But others, the geomagnetic reversals are just 50,000 years apart. So in 1960, it's like in the mid 60s that we were able to use these, the magnetic qualities of the rock to demonstrate and prove exactly how and where plate tectonics works. We didn't know that until the mid 60s.
This is the theory. This is the thing from which all these other geophysical understandings was derived?
Yeah, we hypothesized geomagnetic reversal, a thing that has not happened in tens of thousands of years, and then used that to prove that the seafloor is spreading apart, a thing that, had been observed in the 14th century. But it was in the late 60s. Like President Kennedy got shot and he never knew. He never learned how plate tectonics worked. That's how recent that is. It's weird.
It's weird. I remember when it was still the subject of magazine articles.
Like it would be continental drift.
Yeah, right.
Because it appears the continents are moving around, but what?
I mean,
how?
This was the theory in the 60s, but it wasn't like popularly disseminated until we were reading magazines.
It wasn't science.
But now explain what happens. Like, what is it perceptible at any level other than? I mean, my sense now that we have so many things flying in outer space, so many things using GPS, that a switch in the polarity of the Earth might have some crazy consequences.
It's gonna bug us more than it did the Neanderthals.
Yeah, but 150 years ago, if the polarity of the Earth had flipped, would anyone have noticed other than the compasses flipped around?
The guy holding a compass. Yeah, the compass companies are like, we got to start putting an S on top. Oh, man. We're going to have to recall like 600 compasses.
Does it have real world effects, or is it all just at a subatomic level?
It does. I mean, before I get to that, let's talk about what causes the flip. Because it's not intuitively obvious that it would just flip, right? I mean, shouldn't it be happy with North Pole being north? Like, what's going to change?
Well, is this magnetic action under the crust? Is it, as it swirls, does it alternate? Does it flip around?
Yeah, that's what's happening. It's the swirling. So, again, we don't know. This hasn't happened in 780,000 years. We haven't had a good one. So this is not something we...
Rubbing my hands together.
Waiting for the big one. This is not something we can observe. So we can theorize and we can run computer models. Obviously, I'm speaking to futurelings who have probably seen reversals come and go, and maybe they know more than me. But in our era, our knowledge is limited to running a computer simulation. And the question is, are these triggered by some abrupt outside event, or is the magma just swirling away and eventually it swirls just right? It could be catastrophic. Imagine some kind of impact event, a meteor hits the Earth and shakes up the tectonics, and then boom. Or some kind of mantle plume, really hot rock coming up from the mantle to the crust. A tectonic plate pushes downward in some crazy way, disrupting some system at a plate boundary. If you disrupt a system like that, you're essentially rebooting the Earth. And the theory goes, well, there'd just be a 50-50 chance that it would come back up pointing south again.
Right.
Like you're rebooting your router and hoping that it works. However, there's a problem, which is that there's been, we have the fossil record of plenty of comet and asteroid impacts that do not appear to be linked to a geomagnetic reversal. So it's not foolproof. What is maybe more likely is that as the core swirls beneath us right now, it's creating little instabilities and new magnetic fields everywhere. Geophysicists call this secular variation.
It's kind of a weather system of magma.
Exactly. It's like hurricanes are forming under our feet right now. And typically, when something weird happens, the Earth's magnetic field is strong enough that it will quickly fall into line with the prevailing field. That's what tends to happen in simulation. But not always. Sometimes little competing poles will appear. And it's just like weather. It's like a hurricane appearing. And it'll move about 1 degree a year. In our era, there's currently... the biggest one is kind of under Brazil and the South Atlantic right now.
Oh,
a hurricane of competing magnetic field.
And you can measure that from the surface.
You can measure it with a magnetometer. It's not like if you go to Brazil, your compasses are going to point south because you've still got the Earth's magnetic field. But yeah, under your feet, measurable stuff is going on.
That makes you want to
dance,
wear a very small bikini.
That's right. It makes you want to samba, basically. It's the sambatic field. And occasionally, one of these hurricanes gets big enough that, it kicks off whatever chain of dominoes that will take over the Earth's magnetic field, and you get a flip. That's the other theory. It's gradual.
So, in addition, since this is all new science or speculative, we also don't really know what effect the magnetic field is having on. It could actually be responsible for the samba.
Right.
We don't know how powerfully it affects.
We can look at
Earth
places.
events.
We can look at places where the magnetic field is very weak, like Mars. Mars does not have a geodynamo under it. It does not have a molten moving surface like we do. Maybe it did, but now it's dead.
Right.
And we can see that things are not so great on Mars. Venus has no magnetic field at all, which is kind of an oddity.
Does the moon have? The moon isn't alive inside, is it?
Yeah, the moon's like Mars. The magnetic field is very weak. And it's consistent with not having any kind of molten geodynamo at its core. There's maybe stuff going on in the crust with ferromagnetism, but that's all you get.
Right.
So, is it possible that a magnetic fieldless Earth would look like the moon? And if so, what happens when it changes? We don't know how gradual the process is.
Oh, because it's happening on a time scale where it could be 24 hours or it could be 250
Yeah, I mean,
years.
is it the kind of thing where just somebody is going to happen to have their compass out right when it goes whoop, and he'll be like, I got to get on my cell phone. The current estimates say that on average, this is going to be a bit of a disappointment if you're hoping for a crazy fun day out.
Right.
Somewhere between 1,000 and 10,000 years.
So it could, the reason
field
that
to change
the
over.
deviation now is 3 degrees or whatever between the magnetic pole and the actual pole. This could be the beginning of the process. This could be us watching it start to veer.
It could be. I mean, we're overdue. I mean, if this tends to happen every 200 to 300,000 years, although there's a variation, sometimes it's 50,000, sometimes it's 50 million, then the fact that we have not had a good one for 780,000 years means we could be overdue.
Oh.
And yeah, if stuff's drifting around, maybe that's a first sign.
Oh, it's too bad that it doesn't happen just really fast.
Well, maybe it does. There are some lava flows in southeast Oregon where you can actually see new lava appearing very fast. And in some of those, the striations of magnetic polarity are so close that it looks like the magnetic pole then was moving 6 degrees per day. I mean, and that doesn't mean it was over in 60 days. Am I doing the math right? 6 times 60, 30 days. It doesn't mean it was, a month-long special, because there's probably a lot of blips and reversals. But even so, that suggests that maybe it could be something that happens over 50 or 100 years,
right,
as opposed to 10,000 years.
And there would be some manner of magnetic or magmatic storm under the surface of the Earth, effectively.
Yes. And what does that mean for us? There are probably some real-world implications if the human race survives long enough to see one of these. In fact, even though I said the last good one was 780,000 years ago, there was a 440-year excursion, is what geophysicists call it, where the pole goes for a walk. The pole kind of wanders to the other side of the Earth and then thinks, nah, I'm going back. And that was just 41,000 years ago, the Lechamp event. 41,000 years ago means there's people living in settlements and painting badly rendered bison on cave walls.
How far did it meander?
I think it flipped all the way. It just didn't take.
Oh.
So we had kind of a 440 year of, she loves me not. Maybe there's some bouncing back and forth, I would guess. And only for it to resettle at our current North Pole. But during that time, the magnetic field would have weakened substantially. During the Lechamp event, it's estimated that the Earth's magnetic field got down to, it was 95% lower, only 5% of its current strength.
Have you always wanted to learn to play an instrument? Maybe you've even tried at some point, but gave up because you felt lessons were too expensive or that you just didn't have the time. Thankfully, there's Musician. Musician is the fun, easy, and affordable way to learn guitar, piano, bass, ukulele, and even singing. Just download the app to your desktop, tablet, or phone and start playing. Musician gives you 24/7 access to a vast catalog of video lessons from professionally trained educators, as well as thousands of exercises and songs across dozens of music genres, all tailored to your goals. And with Musician's award-winning technology that listens to you play, you'll get real-time feedback on timing and accuracy so you can actually see yourself improving as you learn. Start your extended 14-day free trial of Musician's Premium Plus package at musician.com/start. That's unlimited access to thousands of lessons, exercises, and songs on as many instruments as you want for 2 whole weeks. Just go to musician.com/start. That's YOUSICIAN.com/start.
And what is the magnetic field doing that we could lose 95% of its power and still bison are getting drawn, loincloths are being worn? Like, would it have been noticeable on the surface?
Maybe not to humans, certainly to animals, though. I mean, we have a lot of animals that use the Earth's magnetic field to navigate, right? Birds migrating.
Whales.
Yeah, sea turtles. I know you were recently swimming with the sea turtles in Maui.
I was, only a couple of days ago.
Could you tell? Did you hold up one of your Wile E. Coyote magnets to confuse them?
Well, I was struck by the fact that a sea turtle cannot really have too many plans, given the way they're living in an ocean that is like ebbing and flowing, and they're borne by these currents. Watching sea turtles, if they're on their way to somewhere, they have to have a pretty easy does it attitude about it.
Like in Finding Nemo. That's why they're chill surfer bros.
And it made me think, because I was in Maui for a long time and was chilling pretty hard and was looking for aloha, I thought, what are like the waves that are affecting me in my life that I'm like not like super aware of because like I'm living in them?
Are you trying to be more like the turtle, like more agile?
Yeah, well, no, I was like looking at the turtle and like, whoa, like you are totally like one with your environment, bro. And like, I am just I'm like always fighting it because I'm like a human, and like, what if I just like used my own magnetism and just went with the waves?
You realize you're totally doing the voice from Finding Nemo. Like,
I didn't know. I haven't.
Your idea of this turtle came 100% from Pixar.
No, I've never seen Finding Nemo. Is that right?
Yeah.
Did I just stumble into a universal truth?
You have reverse engineered, I guess, the voice that we all associate with sea turtles.
That is a voice that's very familiar to me from my own upbringing, surrounded by ski bums who are just surfer bros by another name.
It's true that if there were mountain turtles, they would probably talk like skiers.
For sure.
But because they're in the water, looking for a good wave, I think the idea was, why don't they sound like surfers?
Surfer bros.
But, interestingly, when they migrate, a lot of these sea turtles are not just going where the waves take them. Like, a lot of them really...
They do have a plan.
Yeah. God laughs at your sea turtle plan. I mean, they have a general plan. Obviously, in the micro scale, they're getting washed around a lot.
But they have somewhere to be.
Yeah, they have somewhere to be. They know, these turtles will just get out of their eggs on the Florida coast and just make a beeline for the ocean and then just swim to Africa. Like they'll just that's like they're wired to do one thing, which is to turn right at the Canary Islands and head to Africa. And we now know how they do this. They instinctually can respond to these little secular variations in the Earth's magnetic field. Like
wow.
These things have a long enough geological scale that animals can evolve to, the pattern's a little weaker here by the Canaries. That's how I know to take a right. And in fact, if you put a sea turtle in a swimming pool with your Wile E. Coyote magnets, you can actually make it turn the right direction by simulating specific geomagnetic conditions.
Really? So if the poles had a dramatic event...
Yeah, turtles are effed.
and maybe all kinds of things. Birds would start flying into the sun, dogs and cats sleeping together.
Mass hysteria. But it's, there's an upside for humans. As we watch all the turtles die, the aurora borealis is going to be beautiful.
Oh, that's nice.
It'll be further south.
Yes.
So you won't have to, try to go to Iceland in the winter and hope that it doesn't rain the whole time. You can actually just sit at home in Wyoming and on your veranda, and it'll be beautiful.
The apocalypse has so many like unintended consequences
Right.
that are like beautiful sunsets.
Wyoming is underwater for sure, but in your rowboat, as you circle above the little weather vane of your barn, which is all you can see, the aurora will be lovely. But what if it lasts too long? Like, what if we get tens of thousands of years with no strong magnetic field? That's when things start to get a little dicey, because one of the things the Earth's magnetic field does is it helps divert a lot of these high energy particles coming from space. We're getting bathed with cosmic rays all the time.
And the magnetic field forms a protective layer of exo-atmosphere.
Yeah, we got a little cocoon. I mean, we also have the atmosphere. The atmosphere is great. Atmosphere keeps a lot of that stuff away.
Look, I would never say a bad thing about the atmosphere.
I think I am on the record as being extremely pro the atmosphere. All my friends know.
I know.
But in addition to that, you've got a magnetic field kind of deflecting a ton of stuff. And if that goes away, suddenly you've got the potential for, say, a coronal mass ejection from the sun, or normally that would have been swept aside. What if it puts a massive hole in the ozone layer? And what if high energy particles then start to bombard us and turn us all into the Fantastic Four?
Is the magnetic field potentially why there is an atmosphere? Like, what?
It's an interesting question, right? Because Mars doesn't have one.
Right.
And the moon doesn't have one. And that's associated with...
Like, which came first? I think probably the magnetic field came long before the atmosphere.
Yeah, it certainly seems likely that, this is stuff that might have gotten... it's hard to model all this stuff over a period of billions of years, and I'm sure it's a super complex simulation to run. But yeah, it seems very plausible to me, a person who knows nothing.
Sure.
But just read a very short article about this.
Hey, don't discredit all the little short articles you've read in your life that all string together.
At some point, Motonari Matuyama didn't even have Wikipedia. He's just going around picking up pieces of basalt. You got to go with your instinct sometimes. But yeah, so like, what if cancer rates go up? That could totally happen if we're all getting bombarded with more stuff from space. It's probably not great for power grids.
No, definitely not. But how does GPS work?
Yeah, exactly.
Relative to the magnetic field, does it work from magnetism, or does it work from something else? Geopositioning, satellites are.
I mean, my understanding is there's enough uncertainty and flux in the Earth's magnetic field that it's not really good for... I mean, our modern geopositioning can tell if I'm in my front yard or my backyard.
Right.
And I think if you were going to use geomagnetic stuff for that, the margin of error would be
too great,
way bigger. Yeah. But communications, I mean, think what happens to, think what happened 30 years ago, at least, to your TV reception during some kind of solar event, some kind of sunspots or whatever that
Dad
is. Solar
had to
flare.
get up on the roof and readjust the rabbit ears.
Standing behind the TV. Okay, just stand there. Hold them till the end of tic-tac-toe.
Did your TV did you ever put tinfoil on the rabbit ears?
I think we had tinfoil on the rabbit ears. So I still do this. I'm a throwback. I don't have cable TV. FutureLinks, we have recently moved into an era in which our communication network tend to come over wiring and not through the air anymore, not broadcast over the air.
You don't have cable TV?
I don't have cable TV. So if I want to watch something that's actually going on now, which almost never happens, I have an antenna. It looks like a piece of typing paper now. Antennas are different than they were, but I have to find a way to hold it. And during the Oscars, a couple weeks ago, occasionally the sound would drop out and I would have to move this thing around, and it was delightful. It was like I was back in the 70s moving my little antenna around.
Is this real? Are you serious?
You don't believe that I have an antenna?
No. You have a home theater that would rival a theater in another person's home.
Yeah, but I don't use it to watch NCIS.
Well, what do you use it to watch?
Almost nothing. A football game, the Oscars.
But how do you get those things?
I have a little antenna that's
Is everything else on DVD? There's nothing coming. Do you watch things on the internet?
Yeah, there's streaming video. There's the internet. I actually do have a lot of physical media, but one option, they do still broadcast all the networks still broadcast over the air. It's just digital now.
Right.
So you have to have a different kind of receiver, and the antennas now tend to look like, again, like kind of a stiff piece of paper that you have to angle right.
Weird.
Do you still have cable?
I don't have a TV.
You watch things on your phone when you need to watch NCIS.
Yeah, to keep up with my shows.
Why were you so surprised that I don't have cable when you don't even have a TV?
Well, it's obvious I don't have a TV because I'm a Luddite, but you are like
I've got a box of magnets.
You're like a media forward person.
You're not a Luddite. You're hanging out at Los Alamos.
Well,
you're science forward.
Yeah, but I'm not media savvy in the same way that, I mean, you're like media consumer.
Yes.
I'm terrible at consuming media.
I found that I was not using cable as much to consume media. I mean, really,
we can all agree cable is garbage.
The people who are locked in are sports fans.
Right.
You know, like they need to see their games. And if, you know, there's some team you're locked into, you are locked into cable or whatever your best workaround
That's
is.
why they have 40 sports channels.
Yes. So we don't know when the Earth's magnetic field is going to flip again. We don't know how long it's going to take. It does seem like mass extinctions, you know, we can see mass extinctions in the fossil record. We know exactly when those are. And they don't seem to be synchronized to geomagnetic reversals.
Right.
So that's a nice thought.
That is nice.
Right? Like this might be, of all the terrible things that could happen, this might be a survivable one. But we don't really know. It seems like these are the kind of things where there's so many unknowns that the people making the models have no idea. Did you see the thing this week about how, like, what if we got rid of clouds?
No.
Like,
is that something we're trying to do?
Yeah.
I don't want that.
It's our new goal.
I like clouds.
It's, I think it's some scientist whose maybe parents were killed by a cloud.
Yeah, that's what it is. He got bit by a radioactive cloud.
He turned into Cloud Man. They're worried that in some of these climate models, like, what if we start some process whereby clouds just can't form anymore? It's not clear. Over Earth's history, there's been a great variability in a lot of clouds, no clouds. Like, when do we hit the point when there's no clouds? And if so, does it create some feedback loop that just raises the Earth's temperature 14 degrees more than we thought it was going to? And the answer appears to be maybe.
Oh, wow.
So something else to worry about on your delightful cloudless Earth, futurelings.
Well, it seems like clouds coming and going, we would notice that right away. But if the magnetic poles shifted, I'm sure there would be a lot of hot takes on it the following day on Twitter. But
then there'd be a video of a llama doing something and we'd forget.
Yeah, like it's amazing that something on such a large scale, something that seems so cataclysmic, could come and go and wouldn't have any like noticeable effect, real-time effect on us.
It's one of the most powerful forces in the universe, electromagnetism, right?
Yeah, right.
And it was something that would affect the whole planet, but you can't see it. People who lived through it maybe had no idea.
Well, I'm so used to being a person from the North, and the North having such a strong affiliation for me with like greatness,
adventure,
that if suddenly like Alaska is in the South.
What if you were a Southerner?
And I was a Southerner, that would really affect my identity, my self-identity.
It's time to buy futures in like black-eyed peas for Canada and Alaska.
I mean, right. If that happens, are we just like, are Alaskans going to have to, I guess we just start acting like our good friends, the Australians.
We have kind of this cultural thing where the North is adventure, and the South is kind of relaxation, sea turtle life.
But I guess
it even happens within cities. You know, typically
sure.
The South side is kind of the, you know, that's not where it's happening. That's not the future. That's not the nice side of the tracks.
It's true at a national level. It's true at a regional level.
Yeah, people often make fun of the backwards South from whatever their nation or landmass.
But
is.
I think that's true as you approach the equator, and then on the other side of the equator, the cultural polarity flips too.
Well, I wonder if cultural North and South is now stronger to us than geographic North and South, so that we would actually keep the words, you know, like the South is still the South.
Yeah.
That was unrelated to magnetism.
Yeah, exactly.
The fact that they really liked hog jowls had nothing to do with basalt.
I bet if it flipped, rather than rewrite every map, rather than change the words, we would just develop a separate set of words for for the magnetism.
Yeah, North and South.
Yeah, right. And that concludes Geomagnetic Reversal, entry 524.JB3709, certificate number 41220 in the omnibus. Futurelings, in the unlikely event that social media still exists in your era, Facebook, Twitter, and Instagram, or, as we say after the geomagnetic flip, Facebook, Fitter, and Twinstagram.
Fitter?
I don't know.
Is that like fashion Twitter?
I got lost somewhere in my own joke. Those are archived at Omnibus Project on the various handles out in elsewheres.
The various handles?
Burb.
Like the CB radio handles?
Derb. I flew in from Hawaii, and it was a very rough flight, a red-eye flight, and
I always think the red-eye back it's a little cheaper, and then it just ruins my whole week, and I think, good thing I just saved $80
I'm so
to
groggy.
ruin my week.
It's really bad.
You should have swum back with the turtles.
I should have. I'd be here in June. You can find us at John Roderick, at Ken Jennings, across all media. We'd love to get your emails. We've had a little bit of an email switcheroo in recent days, and we have a new email address now.
Future-proofing for the cataclysm.
That's right. Please make a note of it in your email boxes so that when we send you spam, it makes it through your spam folder.
Carve it on your cave walls, imprint it on your crystalline forebrains.
Here
Whatever
it
needs
is,
to happen.
our new email address, theomnibusproject@gmail.com. That's theomnibusproject@gmail.com. Theomnibusproject@gmail.com.
Theo M. Nibus Project at gmail.com.
You can contact us on Facebook through our Omnibus Futurelings group. When I say contact us, I don't mean directly. You can communicate with other Futurelings, and the message sometimes gets to us. Ken will go on and correct mistakes. I will occasionally appear and be super mad that someone is trying to, actually me.
If you ever see a really long paragraph block of text on the Future Lakes thing, John has just logged on.
It doesn't happen that often, but every once in a while, I'll say, I beg your pardon, sir.
Today we have people telling us how to say Louisville, Kentucky.
Louisville.
That's correct.
Louisville.
People talking about their high school nicknames.
I bet every Futureling had some kind of clever, quippy nickname. Sometimes at their expense. Sometimes bullies nicknamed them.
Some cool lantern slides from early Mount Everest expeditions. It's a treasure trove.
It's nice there. Also, today Ken came over and we had a great mail opening session. We got
little mail sesh.
We got some very cool items. I'm wearing a hat right now that says Omnibus Project on it.
I feel kind of bad that whoever sent that has been more timely about making merch than we have.
It's a great piece of merch, a great sample piece of merch that we may duplicate when we come out with merch for you.
The Futurelings won't know. They'll find all this stuff in archaeological digs from thousands of years ago. They won't know that it literally took us a year to get our shirt act together.
Ken got a great Hilbert Hotel shirt in the mail. I didn't get one, but I did get a pair of very fancy jeans, denim blue jeans.
I actually got an infinite number of Hilbert Hotel t-shirts, and I'm just going to pass mine along to you because I know I can just put on the next one.
But they're infinitely too small for me.
Yes, they are infinitely too small. I'm sorry. We did not get infinite sizes.
But we get all these nice packages and weird things at our P.O. Box, which is P.O. Box 55744, Shoreline, Washington, 98155.
Listeners, from our vantage point in your distant past, where I'm still trying to get my act together, Ray t-shirts, we have no idea how long our civilization survived. We hope and pray that the catastrophe we fear, possibly triggered by geomagnetic reversal, may never come. But if the worst comes soon, this recording, like all our recordings, may be our final word to you. We certainly hope that Providence will allow, the magnetic juggalo gods will allow us to be back with you soon for another entry in the Omnibus.